Dear students, today we are going to solve question number 10 of exercise 10.4. Find the area of the parallelogram whose adjacent sides are determined by the vectors A vector and B vector. Nangon the parallelogram amapire parallelogram sigi adjacent sides se A vector ga B vector ga na represent a record. Then find the area of the parallelogram. First, write components of A and components of B. Draw a parallelogram ABCD. This AB side is represented by A vector and AD side is represented by B vector. Then find A vector cross B vector. A ga B ga cross product lausiko is equal to expansion of the determinant ijk. Write the components of A 1 minus 1 3, components of B 2 minus 7 1. Expand to 12. Expanding the determinant along first row, we get this vector 20ik plus 5 times of j minus 5 times of k. This is the cross product of A vector and B vector. But the area of the parallelogram. Area of the parallelogram is given by the magnitude of cross product of any two adjacent sides. That is AB vector and AD vector is equal to AB vector cross B vector. Then find the magnitude of AB vector cross B, which is equal to root over x component square. 20 square is equal to 400. 5 square is equal to 25. Minus 5 square is equal to 25. And their sum is 450. Prime factorization of 450 is 3 square into 5 square into 2, which is equal to root over 15 into root 2 square units. Sumain taraga nangi area of the parallelogram sa kaiga manare 15 root 2 square units. Next question is question number 11. Let the vectors A vector and B vector be such that magnitude of A is equal to 3, magnitude of B is equal to root 2 by 3, then A vector cross B vector is a unit vector. If the angle between A vector and B vector is hierarchy option A, option B, option C, and D here option mari pireko. Stagi nang na correct option khan se karamba chungge se. We have magnitude of A is equal to 3, magnitude of B is equal to root 3 by 2, root 2 by 3 lereko. And A vector cross B is a unit vector. A big cross product is a unit vector neighbor, which implies that their magnitude will be equal to 1, which implies that magnitude of A into magnitude of B sin theta, and the magnitude to 1 tagrabani na n cap to 1 chalani ko. Sin theta is equal to 1, 3 into root B si kay gamane, magnitude of B se root 2 by 3 ni ko. Sin theta equals to 1, then cancelling 3. Sin theta is given by 1 divided by root 2. Dudi theta ki karamba value that 1 by root 2 tage haitari theta sina pi by 4 orakan ko. Tunangi asumbo option se option number kya tare? Option number B se ore ko. Next, let us solve exercise example number 30. If with reference to the right-handed system of mutually perpendicular unit vectors I, j, k, if alpha vector is equal to 3i cap minus j cap, beta vector is equal to 2i cap plus j cap minus 3 times of k, then express beta vector in the form of beta 1 plus beta 2. The beta vector says sum of beta 1 and beta 2 they express the where beta 1 is parallel to alpha and beta 2 is perpendicular to alpha. Beta 1 sina alpha da parallel oiba, beta 2 sina kanada perpendicular taba, alpha da perpendicular taba ko. Sige question si mo yengase. Example number 30. Here we have two vectors, alpha vector and beta vector. Write the components of alpha and beta. Since beta 1 vector is parallel to alpha vector, beta 1 se alpha da parallel na beta 1 se kaide express to ni lambda alpha ni ibiani. Lambda se any scalar ni ko, where lambda is a scalar. Nangi lambda se any scalar ni. Then alpha, all the components of alpha vector should be multiplied by lambda. We have 3 lambda I cap minus 3 lambda j cap. Sumain taraga phange ko. 3 lambda I cap minus lambda j cap. Then write B vector. B vector se kamaina irani beta 1 vector plus beta 2 vector ireko. Find beta 2 vector. Beta 2 vector is equal to beta vector minus beta 1 tare. Ani si subtract taw na si ko. Subtract taw bagana kayo na fangani. Beta vector minus beta 1. Beta si laire stagi ng beta 1 kaidok tare ko. 2 minus 3 lambda I cap plus 1 dagi kana khaido ani minus lambda minus minus t plus hoina chale ko 1 plus lambda j cap and minus 3 minus sidanang k cap yaubra k cap yaudраbanina 0 k cap hairaneba minus 3 minus 0 is equal to minus 3 k cap sumain taraga nangi beta 2 vector se phangba ngame components of beta 2 vectors are 2 minus 3 lambda I cap 1 plus lambda j cap and minus 3 k cap simong de itoeka. Since this beta 2 vector is perpendicular to alpha vector, their scalar product will be equal to 0. Nangi beta 2 vector se kanada perpendicular taba alpha the perpendicular taba maramna scalar product se 0 tarani ko. And find the scalar product of alpha and beta, which is equal to sum of product of corresponding components of beta 2 vector and alpha ni ko. This 2 minus lambda multiplied by 3. See 3 ireko plus 1 plus lambda multiplied by minus 1 and last component minus 3. It should be multiplied by 0, which is equal to 0 tareko. 6 minus 3 3 minus lambda 1 plus minus 1 lambda into minus 1 is equal to minus lambda 0 sale. Implies that minus 9 lambda minus lambda is equal to minus 10 lambda. 6 plus minus 1 is 5. By solving this equation, value of lambda is equal to 1 by 2. 1 by 2 when fange ko. Nangi lambda gi value se 1 by 2 tare. Then substituting these values in beta 1 and beta 2. Beta 1 gi component, beta 2 gi component sida lambda gi value substitute tare. We have beta 1 is equal to 3 by 2 I cap minus 1 by 2 j cap. And components of beta 2 are 1 by 2 I cap plus 3 by 2 j cap minus lambda. See that 1 by 2 hapaga solve toraga sigi component naam se fange ko. So example number kya gino? Example number 30. Next, we are going to solve miscellaneous exercise. Miscellaneous exercise on chapter number 10 ni ko. So the selected oina khalle ahanbada question number 6 yoni yengase. Find a vector of magnitude 5 units. Nangi vector sigi magnitude se 5 units labor ko, and parallel to the resultant of the vectors A vector and B vector. Resultant haidi kaino sum of the two vectors haibani ko. Question number 6. Haziki sum of the two vectors magi resultant se the ek tauraga laiba unit na 5 magnitude changba vector ama putho haiba ko. The first A vector B vector components ire resultant of A vector and B vector is given by A vector plus B. Find the sum of corresponding components of A vector and B vector, which is equal to 3 I cap plus j cap plus 0 k cap tareko. 2 plus 1 3, 3 plus minus 2 j minus 1 plus 1 the 0 saleko. And sum of these two vectors is represented by C vector. C vector hareseba. C vector haibadagi dekhoina C cap se puthongni ko. Therefore C cap, any unit vector acting along the resultant of A vector and B vector is given by this C vector divided by magnitude of C vector, which is equal to 3 I cap plus j cap plus 0 vector divided 0 cap divided by magnitude of 3 square 9. 1 square is equal to 1 and 0 square is equal to 0. Sitare ko si solve already 3 I cap by root over 10 plus j cap by root over 10 si phange. Si kaino hai tardi nangi resultant of two vectors to the ek toriba unit vector amneba. Unit vector haidi kaino haradi mo. Unit vector is a vector of magnitude 1. Magnitude 1 tab. Hauzik puthok tu isina magnitude kya leba? Magnitude 5 leba ko. And therefore the required vector of magnitude 5 units is given by 5 times of this C cap. Nangi C cap to the 5 na multiply taurani, which is equal to 5. Write the components of C cap and their product is equal to 15 I cap divided by root over 10 plus 5 j cap divided by root over 10. Step hangiba vector sina nangi resultant of two vectors to the parallel oina ek toba magnitude na kya oiba 5 units oiba vector duni ko. Next question is question number 10. Now question number 7. If A vector equals to I cap plus j cap plus k and B vector equals to 2 I cap minus j cap plus 3k and C cap pire ko. C vector minus the vector sahum pire, then find a unit vector parallel to the vectors 2 times of A vector minus B vector plus 3 times of C vector. Sigi expression sida ek tauraga laiba parallel usida parallel oina ek tawra leba unit vector sama putho haiba ko nangonda vector kya pire vector hum pire there are three vectors a vector b vector and c vector and we write all the components of a b c component lo ire ko then find the value of this expression 2a vector minus b vector plus 3c vector which is equal to kaitane 2a vector means all the components of a vector multiplied by 2 right hape ko then mathang da minus b haitardi all the components of b vector should be multiplied by minus 1 minus 2 minus plus minus the chale ko then last ki 3 times of c vector all the components of the c vector multiplied by 3 I cap minus 6 times of j cap plus 3 k cap. Then find the sum of corresponding component. 2 minus 2 cancel to 3 I cap ko 2j 2 plus 1 is equal to 3 minus 6 is equal to minus 3j cap cancelling minus 3 and plus 3 we get 2 times of k so minus 3 I cap minus 3j cap plus 2k cap hange ko and the value of this expression is represented by d vector. D vector haibasina represent the whole ko. So d vector na represent re then find a unit vector acting along this d vector which is given by d vector divided by magnitude of d. Write the components of d vector 3 I cap minus 3j cap plus 2 times of k divided by root over. Components of d vector are 3 minus 3 and 2 niko. 3 square is 9 minus 3 square is 9 2 square is equal to 4 tare do sum whole 9 18 plus 4 is equal to 22 then divide 3 I cap by root over 22 minus 3j cap by root over 22 and 2k cap divided by root over 22. These are the components of d cap. D cap is a unit vector acting along a vector of expression 2a vector minus b vector plus 3 times of c vectors the piriba vector gi expression je vector amadi tadwini ko mangonda ek tawba unit vector se c vector se uri. Next question number 9. Find the position vector of a point r which divides the line segment joining the 2 points p and q whose position vectors are 2a vector plus b vector a vector minus 3b vector externally in the ratio 1:2. Also show that p is the midpoint of the line segment rq. Rq haiba line segment sigi midpoint ne so to haiba ko nangon the point ani pire there are 2 points p and q with position vector 2 times of a vector plus b vector and position vector of q is a vector minus 3b vector. If there is a point R which divides the line segment PQ externally in the ratio 1:2 the ka then find the position vector of R. Position vector of R position vector ibagi mong se take ko nangonda R haibam laires then P laires then Q laire ko. This R divides PQ in the ratio karamba ratio the ka 1:2 the ka ko 1:2 the ka sina position vector of p position vector of q laidwini mamang da takibada internally haragana sigi formula se plus tagadabne externally haragana minus oidwini ko kamai lakani haitardi 1 should be multiplied by position vector of q then these two should be multiplied by position vector of p divided by haraga internally or this is sign animak se plus ta tare externally oragana animak se minus oitare ko. Therefore position vector of r will be equal to 2 multiplied by position vector of p minus 1 multiplied by position vector of q divided by 2 minus 1. 2 times of op vector. Op vector se component is equal op vector multiplied by 2. 4 times of a plus 2 times of b minus oq vector multiply the components of oq by minus 1 minus a vector plus 3b vector. For a vector dagi minus a lagthokradi 3a vector ko 2b dagi sigi 3b se hapsin tardi 5 times of b vector sina kanagi position vector no which is the position vector of the point r. which divides the line segment PQ externally in the ratio. Karamba ratio the kaki 1:2 the ka. Then second part is we have to show that the point P is the midpoint of the line segment QRQ. RQ have a line segment sigi kaine have midpoint oi have a midpoint oi means akoina kanagi value puthokani midpoint of the position vector of QR will be equal to position vector of P have a seta doineva. Now find the position vector of midpoint of the point Q and R. Sigi position vector ito any point amana RQ gi midpoint oi taragadi RQ se karamba ratio the kakani 1:1 the kakani ko, and so the position vector of midpoint of any two points is given by position vector of first point plus position vector of second point divided by 2 dune. In case of Q and R, the position vector of Q plus position vector of R makada kaina divide taw tare 2 na divide tawre ko. Then write the components of position vector of Q vector position vector of R. Position vector of R se hausi hot ki bado phangre ko ani se sampu to 3A vector plus A mana vakhale 4 times of A minus 3B plus 5 times of B is 2 times of B vector divided by 2. We have 2A vector plus B vector. 2A vector plus B have a city kanagi position vector oi, which is the position vector of the point P. Have the midpoint of QR se position vector of P ga manaramba maramna point P is the midpoint of line segment QR have a sigi line segment oi reba. Similar ko asina question number 9 ge. Next question is question number 12. Let A vector, B vector, and C vector ang vectors ahum leire ko. Find A vector, D vector, which is perpendicular to both kanada perpendicular oiba A vector and B vector. And C vector dot B vector is equal to 15. There are three vectors, A vector, B vector, and C vector. Then we are going to find A vector, D vector, which is perpendicular to both A vector and B vector, and C vector dot D se kya tagadaba 15. Nangonda vector ahum pire, D have a vector ama puthokadaba. D have a vector se A ga B ga perpendicular taba ko, aduga C ga D ga gi dot product lobaduna 15 oina phangba. Today write all the components of A vector, B vector, and C vector, and also we let this D vector components of D vector are xi cap, yj cap, and the zk cap. So my lower since D vector is perpendicular to A vector, which implies that D vector dot A. D sina A the perpendicular oitaraga D scalar product 0 chatneva ko. Find the scalar product of D and A. D ke A ga puthok tara D 1 into x tare ko 4 into y is 4y, 2 into z is equal to 2z is equal to 0. Write equation number 1. And also D vector dot B is equal to 0 tane, since this D vector is perpendicular to B. D ga B ga se perpendicular oibanina scalar product to 0 chatkani ko. Scalar product log se 3 multiplied by x, 3x, minus 2 into y is minus 2y. 7 into z is equal to 7z, which is equal to 0. Write equation number 2 tareko. And also it is given that C vector dot B D vector is equal to 15. 15 or C ga D ga muglaw siko 2 into x minus y into z, and 4 into minus 1 into y tagre. 4 ga kanaga multiply ta or ni z ka kay ga manare 15. Sumain taroga equation kya fange? Equation ahum later ko. Here we have three equations. By using these three equations, we need to find the values of x, y, and z. Step period equation ahum se use tawraga x, y, z ki value hot to ni ko. Dudi kamain tawraga hot pe yai se hani yang se. Han bada equation number 1 ga equation number 3 ga se hani yang se ko. If we multiply equation number 1 by plus 2, 2 na multiply tawar di 2x, 8y, and the 4z. 2x ka 2x ka manadra, 4z ka manare ko. The subtract or se multiplying equation number 1 by 2 and subtracting from equation number 3 we get equation number 3 is an easy ko. First write the left hand side of equation number 3, 2x minus y plus 4z minus, then multiply left hand side of equation number 1 by 2. 2x plus 8y plus 4z is equal to, then write this left hand side 15 minus 0, since 0 into 2 di 0 chale ko. Subtract down 2x minus x kay chatkrani 0 y minus y ga minus 8 9 gadi minus 8 sigadi minus 9 y tare ko, and cancelling 4z and 4z 0 chatkre, and 15 minus 0 is equal to 0. We have 9y is equal to 15. Then dividing both sides by minus 9, y is equal to minus 15 by 9 minus 5 by 3 phange ko, nang hozik y gi value phange. Equation number 1 ga equation number 3 ga solve tawba kanda nang y gi value phange. Mathang amuk kana solve tawni haibase mu yengase ko. Handagna equation number 1 ga 2 ga sa sida nang x se eliminate tawsi ko. Eliminate tawba matamda coefficient manabra ni yengase. Coefficient is dana 1 tare, dana kya laire 3 laire, makhada na 2 laire, coefficient amta manade ko. Tudi ahanbada equation number 1 da 3 na multiply tawra. Multiply equation number 1 by 3 and subtracting from equation number 2 we get. Koina 3 dagi equation 1 da 3 na multiply tawra, duga 2 dagi mu subtract tawra ko. Equation number 2 gi left hand side is a 3x minus 2y plus 7z minus. Multiply left hand side of equation number 1 by 3, we have 3x plus 12y plus 6z is equal to 0. Then open this bracket. Minus 3x minus 12y minus 6z is equal to 0. Cancelling 3x minus 2y minus 12y is minus 14y. And plus 7z minus 6z is equal to z. 0 chale ko. The value of z is equal to 14y. Since we have the value of y, then substitute the value of y in this equation. Z is equal to 4 into minus 5 by 3. Minus 5 by 3 gi value hape. Cancel to yabra yadre ko. And value of z is equal to minus 70 divided by 3. Housing ng y gi value phange, z ki value phange ko. Then by putting the values of y and z in either one of the equation, 1 da hapasway, 2 da hapasway, 3 da hapasway ko adun equation number 1 do in hape. Equation 1 da hape x plus 4 into y minus 5 by 3 plus 2z. Value of z is minus 17 by 3 equals to 0. And by solving this equation, we get the value of x is equal to 160 divided by 3. So minus equation 1, 2, 3 use the x ki value phange, y ki value phange, z ki value phange ko. And therefore, the components of the vector is 160 by 3 I cap minus 5 by 3 z cap and minus 70 by 3 k caps. Minus koina vector d sa puthokpa ngam. Next question, question number 13. The scalar product of the vector I cap plus j cap plus k cap with a unit vector along the sum of the vectors 2i cap plus 4j cap minus 5k cap and lambda I cap plus 2j cap plus 3k cap is equal to 1. Then find the value of lambda. Question che kaino haradi scalar product of the period vector siga with a unit vector acting along kanada ek tawraga laiba sum of two vectors. Si vector ani pere ko. Vector ani sigi sum da ek tawraga laiba unit vector duga sigi first ki vector sige scalar product lawba se 1 dai hare ko. Then find the value of kai gi value puthoani, lambda gi value puthoani. For question number 13, let A represents the first vector, B represents the second vector, and C represents the third vector. Smaina kuna representation lawre ko. Then find the sum of kana gi sum hot kani second and the third vectors. B vector plus C. Ani se plus tok sinare 2 plus lambda is equal to 2 plus lambda I cap. 4 plus 2 is 6j cap minus 5 plus 3 is equal to minus 2k cap. And so this B vector plus C vector is represented by D vector. D vector amna represent also D vector na represent already, then find D cap. D cap is given by kaya formula na P D vector divided by magnitude of D. 2 plus lambda I cap plus 6 times of j minus 2k cap divided by 2 plus lambda square plus 6 square plus 2 square. Sina x component, y component, sina z component ko. Solve out to add na 2 plus lambda I cap plus 6j cap minus 2k cap divided by root over 2 plus lambda whole square plus 40 setare. Since question na kay pirame A vector dot d cap. D vector havenate d cap haveniko. D cap means unit vector acting along B vector plus C is equal to 1. A ki component iro, D ki component iro 1 tare. Si scalar niko. Then find the scalar product of these two vectors. Numerator gising se 1 multiplied by 2 plus lambda, 1 multiplied by 6 and 1 multiplied by minus 2, which is equal to 1. Scalar or bagi scalar and laser by cross multiplication 2 plus lambda, 6 minus 2 is equal to 4 and root over 2 plus lambda whole square plus 40. Again squaring on both sides. Squaring tawre. 2 plus lambda whole square habise tare. Sine a ne khalo sine b ne khalo expand to thoe kwa. 2 plus lambda whole square plus 2 into 4 sine b ni. 2 plus lambda na first term do ni kwa. Then 4 square kya sile 16 sile kwa. Root ka square ga cancel to tar di 2 plus lambda whole square plus 40 se fange. 2 plus lambda whole square 2 plus lambda whole square. Left to right so chamana na yawe cancel to gre kwa. Duga 2 into 4 8 C 16 40 multiple of 8 tare. Dividing both sides by 8 we have 2 plus lambda plus 2 is equal to 5. And by solving this equation we get the value of lambda is equal to kya gamana re 1 tare ko. So the piri by expression je solve tawraga khoina lambda ki value se 1 phangi. Last question number 14. If A vector, B vector and C vector are mutually perpendicular vectors of equal magnitudes. A vector, B vector, C vector se amana amada perpendicular taba magi magnitude sina chap manaba vectors naktane ko. Then so that A vector plus B vector plus C vector is equally inclined to kanade inclined to we have A vector, B vector and C vector. The ABC have a mutually perpendicular vectors ahum laire. Atoba vector khale the sum of three vectors ko A vector plus C vector and A vector plus B vector plus C vector is equally inclined to kanade inclined to by A dasu B dasu C dasu. China khoina angle lauraga anka hotoi ko hana diagram ami ase draw x-axis, y-axis and z-axis. And let us assume that A vector is acting along x-axis, B vector is acting along y-axis and C vector is acting along z-axis since they are mutually perpendicular unit vectors. And this OP vector represents the sum of the three vectors A vector, B vector and C vector. Vector ahum dugi sum se OP vector na represent hole ko. Let alpha, beta, gamma be the angles made by this OP vector with x-axis, y-axis and z-axis in anti-clockwise direction. Anti-clockwise direction da lairaga koina alpha, beta, gamma se nangi OP vector siga make to be angle dunia na khalle ko. Let alpha, beta, gamma be the angles made by A vector plus B vector plus C vector with A vector, B vector and C vector respectively in kaida chali anti-clockwise direction da anti-clockwise da lore. Then mathang na kai puthokani akoina hojik tawduise kaino alpha beta gamma se chap manai hena prove tawbase akoina solve tawdoini ko. Question number 14 ge. Question number 14 da vector ABC se equal magnitude lai habani ko aduna let magnitude of A, magnitude of B and magnitude of C is equal to x habase gamana halasi ko. Now A dot Hojik magnitude dot product law say A vector dot the sum of three vectors A vector, B vector and C vector dot product ki formula magnitude of A, magnitude of B have a kind B ki expression se sum of three vectors le ko multiply by cos alpha. Alpha is the angle between kana gi marakta laiba A vector ga A vector plus B vector plus C vector ga sigi marakta laiba duni ko. A dot B distributive law apply to A dot A dot B, A dot C law equals to magnitude of A is represented by X. Then write the magnitude of A, B, C. Representation later banina C dum cos alpha. A dot A is equal to magnitude of A whole square, but A dot B and the A dot C will be equal to 0. See 0 chutney ba. Maram kaigino hai tadi perpendicular tagi ko. If the two vectors are perpendicular, then their scalar product will be equal to 0. And the first term and second term becomes 0. Then write this right hand side. X into magnitude of A vector plus B vector plus C vector and cos alpha. Ire ko. Cos alpha hoche cos alpha is equal to this magnitude of a square is represented by x square divided by x root over a vector plus b vector plus c vector is equal to magnitude ni ko cos alpha. The cos alpha is manaba x ani ka adi x ani sidagi ama ka khitardi x divided by magnitude of a vector plus b vector plus c vector tare ko. Sidai question number kya tharani 1. Then similarly we can find cos alpha is equal to x divided by magnitude of a vector b vector c vector ko. Cos gamma so sigi expression je fangani. Equation 1 2 3 itoe ko. From equation number 1 2 and 3 we get cos alpha, cos beta and cos gamma. Cos alpha, cos beta and cos gamma is equal to x divided by magnitude of a vector plus b vector plus c vector c tare ko. The alpha beta gamma so loi manaramani. Alpha beta gamma is equal to kya horani cos inverse of x divided by magnitude of a vector plus b vector plus c vector. Aduna alpha beta se loi mana taragadi ngasai sum of three vectors in a vector b vector c vector the chap mana ni equally inclined taraga lai. For today let's end here.